Let's analyze a home generator installation scenario and its adherence to the National Electrical Code, specifically focusing on sections 90.7 and 110.12. The described installation involves a contractor cutting the bus and a combination service panel between the main circuit breaker and the bus feeding the branch circuit breakers. Lugs are then attached to all four cut ends, and wiring is run from the main breaker to an automatic transfer switch, or ATS. From the HES, wiring returns to the lugs connected to the branch circuit bus. The question arises whether this method violates NEC section 90.7 concerning alterations, or NEC 2002 section 110.12 addressing the integrity of electrical equipment. Firstly, let's consider NEC section 90.7. This section typically addresses alterations to existing wiring systems. However, in this specific scenario, the argument can be made that 90.7 does not directly apply. The key rationale is that the original wiring remains intact. The contractor is essentially adding a new branch circuit to the panel to accommodate the generator and the associated ATS. This new branch circuit is superimposed on the existing system without fundamentally altering the original wiring configuration. The original circuits continue to function as designed. Now let's examine NEC 2002 section 110.12, which deals with the integrity of electrical equipment. This section mandates that electrical equipment must be installed, used, or repaired in a manner that protects it from physical damage. The concern here is whether the contractor's method of cutting the bus bar and attaching lugs compromises the physical integrity of the electrical equipment. A reasonable interpretation is that the cutting of the bus bar and the installation of lugs, if performed correctly, does not necessarily violate this requirement. The bus bar, even after being cut and fitted with lugs, can still be considered protected from physical damage, provided that the lugs are properly installed, securely connected, and appropriately rated for the electrical load. The key factors determining compliance with 110.12 are the quality of workmanship and the materials used. The lugs must be of the correct type and size for the bus bar material and the conductor size. They must be properly torqued to ensure a secure and reliable connection. The wiring must be neatly installed and supported to prevent strain on the lugs. Furthermore, the overall installation must maintain adequate clearances and working space as required by the NEC. It's important to note that the NEC does not explicitly prohibit cutting a bus bar to install lugs, provided that the resulting installation meets all applicable requirements for safety and performance. The acceptability of this method often depends on the specific details of the installation and the judgment of the electrical inspector. There are alternative methods for connecting a generator to a service panel, such as using a pre-manufactured generator panel or a listed tap box. These methods may be preferred in some situations, as they can provide a more robust and reliable connection. However, the method described, involving cutting the bus bar and installing lugs, is a common practice that is widely used by electrical contractors. To ensure compliance with the NEC, it is essential to follow these guidelines. Firstly, use properly rated lugs that are compatible with the bus bar material. Secondly, torque the lugs to the manufacturer's specifications. Thirdly, insulate all connections properly. Fourthly, support the wiring to prevent strain on the lugs. Fifthly, maintain adequate clearances and working space. Sixthly, ensure that the installation is inspected by a qualified electrical inspector. In conclusion, the contractor's method of installing the generator, involving cutting the bus bar and installing lugs, is generally acceptable, provided that it is performed in a workmanlike manner and meets all applicable requirements of the NEC. It is crucial to emphasize the importance of proper workmanship and the use of quality materials to ensure a safe and reliable installation. Furthermore, consulting with a qualified electrical inspector is always recommended to ensure compliance with local codes and regulations. The NEC is a comprehensive set of standards, and its application can be complex. It is essential to have a thorough understanding of the code and to exercise sound judgment when making electrical installations. The discussion has focused on the NEC requirements and the proper installation techniques for connecting a generator to a service panel. The aim is to provide a clear and concise explanation of the relevant code sections and to offer practical guidance for ensuring a safe and compliant installation. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals who are familiar with the NEC and local codes. Always prioritize safety and seek professional assistance when needed. Let's further elaborate on specific aspects of the generator installation and its compliance with the NEC. The National Electrical Code provides detailed requirements for various aspects of electrical installations, including generator installations. These requirements are designed to ensure the safety of people and property. Firstly, let's discuss the sizing of conductors. The conductors used to connect the generator to the ATS and from the ATS to the service panel must be properly sized to carry the expected load. NEC Section 310.15 provides guidance on conductor ampacity. The ampacity of the conductors must be sufficient to carry the continuous load of the generator, plus any non-continuous loads that may be connected. Secondly, let's talk about overcurrent protection. The generator and the ATS must be protected by overcurrent devices such as circuit breakers or fuses. The overcurrent devices must be sized to protect the conductors from overcurrent. NEC Section 240.4 provides guidance on overcurrent protection. Thirdly, grounding and bonding are crucial. The generator and the service panel must be properly grounded and bonded to ensure a low impedance path for fault current. This helps to protect against electric shock and to prevent equipment damage. NEC Sections 250.4 and 250.8 provide guidance on grounding and bonding. Fourthly, transfer switches are very important. The ATS must be listed for use with generators. The ATS must be designed to prevent the generator from backfeeding into the utility grid. Backfeeding can be dangerous to utility workers and can also damage equipment. NEC Section 702.7 provides guidance on transfer switches. Fifthly, labeling is a necessity. The generator and the ATS must be properly labeled to indicate their function and their voltage and current ratings. Labeling helps to prevent confusion and to ensure that the equipment is used safely. NEC Section 110.21 provides guidance on labeling. In addition to these specific requirements, the NEC also includes general requirements for electrical installations, such as the requirement that all equipment be listed or labeled and the requirement that all work be performed in a workmanlike manner. It is important to carefully review all applicable requirements of the NEC before installing a generator. The NEC is a complex document, and it can be difficult to understand all of the requirements. If you have any questions, it is best to consult with a qualified electrical inspector or engineer. They can help you to ensure that your generator installation is safe and compliant. Here are some additional points to consider regarding the installation of a home generator with an automatic transfer switch and its compliance with the National Electrical Code. We'll focus on the specific details of the connection method described, where the bus bar in the combo service panel is cut and lugs are used to make the connections. Firstly, lug selection is critical. The lugs used to connect the generator wiring to the bus bar must be appropriately sized and rated for the conductor size and the bus bar material. The lug should be listed for the application and installed according to the manufacturer's instructions. Factors to consider when selecting lugs include the conductor material copper or aluminum, the bus bar material copper or aluminum, the conductor size in American wire gauge or KC mil, and the ampacity rating required. Secondly, bus bar preparation is key. Before installing the lugs, the bus bar should be properly cleaned and prepared to ensure a good electrical connection. This may involve removing any oxidation or corrosion from the surface of the bus bar using a wire brush or other suitable cleaning method. The bus bar should also be inspected for any signs of damage or wear, and any damaged sections should be replaced. Thirdly, torque requirements are important. The lugs must be properly torqued to the manufacturer's specifications using a calibrated torque wrench. Over-tightening or under-tightening the lugs can result in a poor electrical connection, which can lead to overheating and failure. It is important to follow the manufacturer's torque specifications carefully and to retorque the connections after a period of time to ensure that they remain tight. Fourthly, conductor support is a must. The conductors connecting the generator to the ATS and the ATS to the service panel must be properly supported to prevent strain on the lugs and the bus bar. The conductors should be secured using cable ties, clamps, or other suitable methods. The support should be spaced appropriately to prevent sagging or excessive movement of the conductors. Fifthly, clearance and spacing are important. The installation must maintain adequate clearances and working space around the electrical equipment as required by the NEC. This includes clearances for access, ventilation, and maintenance. The equipment should be installed in a location that is protected from physical damage and environmental hazards. Sixthly, inspections are necessary. The completed installation should be inspected by a qualified electrical inspector to ensure that it complies with all applicable requirements of the NEC and local codes. The inspector will verify that the equipment is properly installed, grounded, and protected, and that all connections are secure and reliable. Now let's delve into the specific NEC sections that may be relevant to this type of installation. NEC Section 110.3b requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. This means that the lugs and other components used in the installation must be installed according to the manufacturer's instructions. NEC Section 110.14 covers the connection of conductors to terminal parts. This section requires that conductors be connected to terminals in a manner that ensures a good electrical connection without damaging the conductors. It also specifies requirements for the use of terminal lugs and connectors. NEC Section 250 provides detailed requirements for grounding and bonding. This section covers the grounding of the generator, the service panel, and the ATS, as well as the bonding of all metal enclosures and equipment. NEC Section 408 covers switchboards and panel boards. This section includes requirements for the construction, installation, and wiring of switchboards and panel boards, including requirements for bus bars and overcurrent protection. NEC Section 702 covers optional standby systems, such as generators. This section includes requirements for the installation, wiring, and operation of generators and automatic transfer switches. It is important to note that the NEC is a complex and constantly evolving document. The requirements for generator installations can vary depending on the specific application, the size of the generator, and the local codes and regulations. It is essential to consult with a qualified electrical professional to ensure that your generator installation is safe and compliant. Finally, remember that electrical work can be dangerous. Always take the necessary precautions to protect yourself from electric shock and other hazards. If you are not qualified to perform electrical work, it is best to hire a licensed electrician.